G'day and welcome back for more Siege Engineers. There are a few more designs we have yet to test, but first what I think we'll do is test this design again. There was a suggestion that I got from a couple of people that I think is worth trialing with this, and that is trying to use a little bit of a greater rotation to allow this thing to get up to speed before it releases the projectile. So right now it's spinning just a bit beyond 90 degrees in order to launch the projectile, but we don't need to limit it to that. We can grab our rotors, and instead of having it go back to 0 degrees, we could add an extra 60 to each. No, we want to add an extra 90 to each. So we'll go to 90 degrees on that one. And then this one. Oh, how do I do this one? Maybe we don't do that. Maybe we take this one to 270 and then we see where it stops and then think about how far we need to get around from there and then use simple mathematics to divide between the three, because I think that's actually the easiest way of doing this. So if we start at 270 and we want to get 360 degrees, so that's going to be 120 for each of these. So this one will go from 270 to 150. This one will go from 0 to 240. So that should work for them now. And that means that I can place the ammunition in this thing. It'll do a full 360 degree rotation, which should give us time to get up to full speed. Maybe. I'm not 100% sure this is going to work, but I think it could be interesting to try. First up, we'll try it with this cup, but I'm suspicious that this little holder is not going to be enough, so I may just add a couple of extra bits just in case. And we'll see how it goes with that. Alright, same as before, we'll reverse our rotors and see how this goes. Now this is shared inertia tensor on. We will try it with both on and off. So 3, 2, 1. And that didn't work. So it released too early. Okay. That means we need this, I think, to be longer to hold it in there. Alright, and launch again. And launching. Okay, it made it a bit further, but it still fell out while it was on the downswing. So, let's try just once more. Few extra blocks, and this is probably going to be a problem since now I've got so many blocks that they're actually going to get in the way, I think. Let's try this. Oh, that is not the way I meant to put that. Like that. That's what I meant to do. Attempt another launch in 3, 2, 1, go! No, still too low. I suspect I'm probably not going to have much luck with this in terms of stopping it from dropping the projectile as it goes around. Though, maybe that might work. Might just be enough to keep it in there. Because it'll just slow it down as it falls down, but it's kind of a sign that... Oh! I did get it to launch! It's a terribly pathetic launch, but it worked! Okay. We'll call that one a fail, I think. So even with all three given a lot more time to accelerate up to their maximum velocities, we still just don't have enough torque on these rotors. So what we could try and do is increase our torque by adding some gyroscopes. Unfortunately, it doesn't really work, and I'll show you exactly why. Now these are going to scrape on each other, but that's not going to be the biggest problem. So there we go, 3 gyroscopes built, and what we're going to do is... Are we at our reset position? We are, aren't we? So if I hit this... Yeah, it fights, it goes that way, and then we can go back. So you can see the gyroscopes there are actually resisting the rotation of the rotors, but what we need them to do is actually try and aid the rotors. So if we get the right angle, we should be able to see what's going on. If we go in here and grab a gyroscope, turn on override. We may just need to turn our rotors off for this. Just to figure out which angle it is that, which of the pitch, yaw, or roll it is that's going to actually make this thing move. Okay, so we want -60 as our roll override. With a timer block, we can set up the catapult to reverse, and we can set our gyroscopes to toggle on and off. So as we turn on the rotation for this launcher, it will also turn on the gyro override. And that should help us get just the top one to 60 revolutions per minute. As you saw, the limits of those overrides are actually still the same as the limits for the rotors. However, unlike the rotors, the gyroscopes are not going to add rotational speed to each other. They are only going to push it up to the top limit of the most distal, I suppose we can call it. Basically, they're going to try and push this one till it reaches 60, then it's going to stop these two from pushing it any faster. Which may still get us a decent launch because this is a reasonably long lever arm, but it's not quite going to do the same as we would hope having all three rotors spinning on each other. Now, we need to change... maybe we'll just add an extra button. So we'll get this button to trigger now on the timer block, and let's see how this one works out. 3, 2, 1. And you can see that actually spun around a lot quicker. If we bring it back, then we try it without the gyroscopes. You can see the speed difference. Bring it back, and with the gyroscopes. Oh, it's about the same actually, isn't it? It does go backwards quicker than it goes forward. Oh no, to me that feels quicker. I could probably put a side-by-side comparison of the two as I press the button. And here we have our comparison. So on the left, we've got our gyroscopes off, and on the right, we've got our gyroscopes on. We'll play through this at full speed, and now at about 60% speed. And you can see convincingly that the gyroscopes have actually made a difference, at least with Share Inertia Tensor on. So let's try that again. Shared Inertia Tensor off this time. Shared Inertia Tensor off. 1, 2, 3. Oh dear. That is very close to the nugget. Very close indeed. Okay, let's try it with the gyros on. Once it settles down a little bit. 3, 2, 1. With the gyroscopes. Yeah. I don't think they're making a huge difference. Whoa! Whoa! Whoa, 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 whoa. Okay. Chill out. Chill out. Alright. That is very scary. You can see why I need to have Shared Inertia Tensor on. Now, since that test didn't really demonstrate what I was trying to demonstrate, what I'm going to do is I'm actually going to take the limits off these rotors. So if we take all these three and give them no lower limit, no upper limit, they're going to... Uh-oh. What did that hit? Oh, it hit the other thing. That's not safe. So now that I've done silly things with this, let's just bring it back to something like that. All right, let's look at the spinning forces here. This is totally getting sidetracked, but I think it's interesting to look at anyway. So let's get our rotors and let's add their speeds together with Shared Inertia Tensor on. So that's 60 RPM, all of them. And you can see all of them are spinning and the top is going pretty quickly. Now, let's turn on our 3 gyroscopes. Oh, wait. Hang on. I think I've got them spinning the opposite direction. So now that they're spinning the same way, we're still going pretty quickly. So you can see with the gyroscopes pushing and the rotors pushing, we can still well and truly exceed the 60 revolutions per minute. However, if we turn our rotors off, now the gyroscopes are, now because the rotors aren't actually providing that extra bit of acceleration, the gyroscopes are capping our speed at 60 revolutions per minute. So, depending on how you set things up, you may be able to use gyroscopes to increase the speed of your launch and make it so things will actually launch faster. But it's possibly not the best way to go about it. There is another method that I, up until today, had not been able to successfully implement. Every time I had tried to get it to work since the old pre-physics update, it had failed. And I finally think I have figured out why. And for this test, we're going to need to steal a thruster from there, and I think there's another one over here. Yep. Okay. Because we're going to put thrusters on the end of this. Now, normally what I would try and do to get thrusters to work in an environment like this is try and keep this thing balanced. So I would put a thruster on this end. I would put a thruster on this end. So one of these thrusters I'm going to turn off, and that's that one. And the other one I'm going to build, and then I'm going to put a thrust override on it. And make sure that the top rotor is turned off, since that's the one we're going to turn on. So it's off, so it's got no resistance to movement, and we can prove that by me pushing it. You can see I am actually making this thing move. Now, this one that is on, we're going to put a thrust override on. And we should, if I've done this correctly. That's the first one. Max thrust override. And it is doing a whole lot of diddly squat. And if you doubt that the other one is off, you can look. Fan blades are not moving. Ooh, it's sort of turning, and then it stopped. And this is usually what I've observed when I've played with thrusters on rotors. It doesn't matter if I put this on a subgrid, so let's do that. We'll still get the same thing happening, and this is just gravity pulling that down. So if we put a rotor on the end here and then put a thruster on that, then we'll grab our atmospheric thruster, set it on override, and basically nothing. But if instead of doing things this way, I take out this whole arm and make this whole thing uneven, and then put this one on, we should be able to get this to spin using just the thruster. And I think I understand why. Here we go. It should get up to a decent speed too. So what I believe is happening, and I may be wrong, but I think this is what's happening, is that the thruster is applying force to the middle of its attached grid. So that meaning the top subgrid. And by moving it out onto an arm like this, it's applying it to the middle of that arm, rather than if I have the arm balanced across with a second one, it's going to apply it directly over the rotor, which means there's no way to make the rotor spin. It needs to have that force offset from the center in order to make the rotor spin. The downside is this doesn't actually get up to that higher speed, as you can see. I can probably improve it slightly by getting rid of this gyroscope. So there's no scraping now. You can see that, yes, that's probably fast enough to kill me. And geez, that was close. But it is not really fast enough to launch something. It's nowhere near the speeds we get up to with this thing. Or with our ballista arbalist sort of thing over here. So while it is nice to know that we can do this, and I'm so pleased that I've finally worked out what I was doing wrong all this time, it's just not going to cut it for a launcher. So it's not going to be the method that I end up choosing. The only sort of spinny device that I think would be really effective as a launcher would be something with advanced rotors built in the center of it, attached to welders with merge blocks on the end, and you spin it up to its highest possible speed with multiple rotors, then have a script pick a particular spot on the combined angle of those 3 rotors, at which point it will release a merge block, and then you can continuously, as fast as you can weld stuff, you can keep launching stuff launching stuff at the enemy, which would probably be one of the most rapid fire designs you could do. But I don't actually have a script that would be able to do that. Octavio did write me a script that I asked him for to help me out with this. But as it turned out, the design that I would have used that on was not going to work. So unfortunately, I didn't end up using that. But I am very grateful to him for writing that script, even though I didn't actually end up using it. There is another thing that I want to test, and it's going to be... well, it's going to be ridiculous. We all know that we can make a vehicle get pretty high up in the air by using the jump command with wheels and suspension. But could we use that to launch something? I am suspicious that we can. And the way I think we'll do that is by building this up to about there. Pop a rotor on here, and then onto that rotor we're going to place a 1x1 wheel. Oh dear. Please tell me I've got another hydrogen bottle. Yes. This design is almost certainly not going to work as I would hope, but it still should be fun to test anyway. Is that turning me the right way? No. I would like to go the other way, because I want to rotate this around until it's at 45 degrees. Perfect. Then we just need a little launch rail. And if we drop this down to its... so let's max our strength out. Our height offset we want as low as possible, like that. This will be our little launch rail. This is an incredibly simple launcher. I don't think it's going to fire things very far, but if anyone manages to come up with a method of properly weaponizing this, you will have to share that with me, because I would love to see this get weaponized. So we might just use a large grid block, I think. Yeah, there we go. Now, because the suspension is the same height no matter which size of wheel we use, the 1x1s are actually the easiest ones to do this with, because the block sits nicely against it, so we don't need to lock the wheel or anything. Whereas if we're against a 3x3 or a 5x5, we'd be kind of getting crushed by the wheel as we push it up. So the 1x1 is actually, at least for a simple setup like this, the best option. And let's see how far this can fling this thing. So we get our height offset, and that was pathetic. Oh, there we go. That was a bit better. Let's try that again with a bit less ramp. Come on, give me the thing, give me the thing, give me the thing. I want the wheel. If not for the rotor, this is normally easy to do. That did not work. Some suspicious part of my problem might come down to the fact that the block that I was trying to fire is actually very heavy, because it's like the mass blocks. I think it may be effectively taking on the weight of 25 steel plates. So this is a bit fewer, but this could end up disastrously because I think it's a bit jammed in there. Yep. That was explosive. Oh. Got some distance out of it though. Yep. Well, even with small grid, that's not really working, is it? But if someone can weaponize this thing, oh man, I would love to see it. So I think it would be awesome. The other option with something like this, in terms of weaponizing it, could definitely be to just use it on the thing you're launching itself. So instead of using these on the launcher, put them on the projectile, and just jump the projectile in itself. But that's probably quite expensive. So that one's a bit of a flop. Let's get rid of that, since my attempts at making it weaponized have definitely failed. The reason it all of a sudden became dark is that I realized after I'd finished my recording that I'd forgotten to point out one of the very, very silly things that I did when I was recording this last time, which is the way that I handled the sensors. They really should be on the arm that has the landing gear that they're actually working for, instead of how I had it, where I had it on the bit that was sticking off the main base. If it's on the arm, that means it'll actually only trigger when it's supposed to, rather than triggering for any of the 4 arms that went over the top. So yeah, very, very silly, but I have messed around with this in creative, and when you're at the really high speeds, the sensors really do not have the ability to detect and effectively when moving at those speeds. So you end up with the whole thing not working properly anyway. The alternative would be to use a script to tell the rotors to release when all 3 of them have their combined angle at the correct angle for the release point. The mathematics and the scripting for that is well beyond me, and to be honest, given that you can get the full speeds out of a system like this, these are probably better anyway, because you don't end up having this thing that's spinning around at 1,000,000 miles an hour that you have to move and move with. Yes, the arms spinning at a high speed might be quite easy to set up a welder for, but they just, I don't know, something about leaving something spinning at that high speed just makes me nervous. A lot less nervous than, you know, bam and bam. Although maybe that should make me more nervous. I'm not sure. Anyway, back to what we were doing, because I did just want to highlight that little thing that I did with the sensors that was really, really, really dumb. And the last thing we are going to build before we choose which design is going to be our actual weapon is a counterweight trebuchet. I was thinking of doing a traction trebuchet using pistons, but it's not terribly different to what I've done here if I were to do that. So I'm going to actually try and make a real counterweight trebuchet using mass blocks as the counterweight. So, in order to do that, we need to do a few things. First off, create a very tall pole so that we can really get some good swing going out of this thing. That should do. Then, rotor on there. So I just separated this one from the other grid so that I can more easily know what's going on. From watching a few things on YouTube and reading a little bit about these, I believe... Oh, we probably want to leave a little more clearance than that. Man, I'm littering a lot of stuff around here. I believe that we need to have somewhere, and depending on the source, between 3.75 and 6 to 1 between the two... between the short arm and the long arm of this trebuchet. So if we have 5 and 10 and we go out 60 on the other side. So that's 60. So now we have our short arm and our long arm. We then want our counterweight, which I'm actually going to hang out this side. I have a reason for this. Dangle it down a little bit. Then it's going to be all of the mass blocks. Oh, I should weld this rotor up so that it doesn't spin so easily. Ooh. Before I let this fall too far, what I'm going to do is I'm going to grab our rotor and I'm going to max out its torque. Because what I want is for this mass of mass blocks, this bunch of mass blocks, to overcome, as in to be more powerful than the force this rotor can generate on its own. So that means I'm going to need a lot of these. Because if it can't overcome the rotor, then it's not really doing anything more than what the rotor could do on its own. So it's not really serving much purpose other than being a ridiculously cool design. Because anything that uses this many functional blocks is kind of ridiculous. We are just barely breaking that force now. Or at least we have been and gradually getting down. But I really want to get this a bit closer to just straight up vertical. That looks pretty good. It's managed to pull it almost completely vertical. It's just a few degrees off. That's definitely going to be able to generate a lot of force. Now we need a way to get this back to its starting position. And I think probably the best way to do that is going to be using pistons. And we're going to need to be able to grab onto either the arm or to the weight, and I think the arm is probably safer, and pull it back up. Because I think pulling down is actually going to be more difficult. So I think the best way to do this is going to be place a couple of pistons going up like this, then bring a couple of pistons across. Yeah, we'll use 2 just in case. Then a rotor on the end of that, and a landing gear on the rotor. No, wait. I just totally did that wrong. Then some more pistons going downward, but these ones I need to build so that I can extend them before we start. So, oh geez. No. That was close. Oh man. I got down to the ground just in time on that one. So, back to our piston mechanism that I'm having all sorts of grief with. So let's put 3, maybe, let's just put 4 just in case. Though I'm pretty sure I don't need that many. Yeah, I don't need that many. May not even need 3. I'll use 3 anyway. So, then we want a block like that, and then we want the landing gear on a rotor. Yeah, there we go. Rotor, landing gear. Now, what we should be able to do once all this is welded is attach this to here, and with this rotor free spinning, oh. So we have a stack of pistons vertically, then we have a couple going horizontally. Then what we need is some going down so that we can get back down to where we were at. Then a block and a rotor and more blocks. That's going to be hopefully long enough. The idea being that this bit will be able to spin on 2 rotors to allow me to lock onto this little arm here, which should allow us to lift this thing up. All right, let's turn this rotor off. We'll leave this one on just in case we need to use it to get into position. But let's extend this piston. That's pretty much right. Then we'll grab one of these ones. And it turns out I've way overkilled on the pistons. Until it locks. Then when the landing gear locks, let's try not to create too much flex in this. Now we can turn this one off so it can free spin. Then we should be able to pull this up by retracting this piston. Oh. Jeez. Look at the flex in those pistons. Oh man. This thing is going to be terrifying. Alright, pistons. Share inertia tensor. Let's make them a bit more rigid. And now let's try and pull this thing up. Okay. And then extend one of these ones. Nice. This is working. This is working. Except for when I interact with the grid by placing something and then the landing gear unlocks. Given that just happened, I might actually change the way I'm going to do this. Landing gear is probably not the way to go. A rotor part might well be the way to go. It's going to be harder to get it to lock on, but once it does, we won't have that disconnection problem that we just had then. Oh yeah, got it attached. I hope that might work. Okay, now we can try this again. See if we can get this to level us off this time. Okay, we're coming down. It's looking good. Well, it seems the way that I've laid this out, I'm not really going to get us beyond horizontal. Even though I would have thought it should be able to do that. I wonder if I can massively increase the force on that piston and get this to work. In fact, let's just grab them all. Aha! There we go. That's what I was looking for. Ooh, that's not what I was looking for. That is not healthy. Oh, that is not good. We've generated gaps in the piston heads with the mass of this counterweight. Okay, it's definitely heavy enough. This is the bit that's a bit more tricky with trying to create a trebuchet in Space Engineers. This should really be a sling and rope. Now, I can kind of make a vaguely rope-like shape, or at least something that's going to function a little bit like a rope, by putting a bunch of rotors like this together with some armor. Now, I am deliberately going to gradually move off to my right here, so that if these end up flipping past each other, they can do so without running into each other. If they run into each other, you may get some torsional forces and some phantom forces that just don't end well for the construction. The biggest challenge is going to be the sling part. Because this isn't too bad for, you know, faking a bit of a rope. But I have no idea of a way to create something that's going to open up as the projectile is as the projectile reaches the top of its arc. Because anything we use in Space Engineers is kept at the same size and also is not affected by any sort of wind resistance, which I think is how a lot of those slings end up opening up anyway. So we may end up having to use a landing gear and do a manual release if a cup doesn't work. Okay, I think that's going to be long enough because I don't... kind of making me nervous going any further than this. Now I got to think about how I'm going to design this cup. What we want is something that's going to hold the projectile in while it swings through all of this way, but then releases it when we reach the top. And I think I have an idea of how to make that happen. So I'm going to weld up all of these rotors and I'm going to set them all to a limit. Because if they all get limited when they reach 0, when they reach straight here, it should release near the top of this thing's arc. Or maybe even slightly shorter than that. This could work. This indeed could work. Alright, so what I've done is made it so all of these rotors, when they reach alignment with the previous... well, how do I say this? This rotor is limited to when it reaches alignment with the arm, and then every other rotor is limited to its current position, basically in a straight line. So once they all reach the straight line, they should all hit, and then the next one will be limited to that. And if I set this rotor here to be limited to about vertical, we should make everything stop and allow the projectile to come out of its cup. Hopefully. If they're all going to stop this thing when it reaches vertical, we should be safe with a cup that's just like our normal designs. There we go. Alright, trebuchet. Oh yeah. I want a nice, easy button to press where I can see everything. I would say that's going to be a pretty decent line of sight. Detach. Now, if I've got that rotor roll and we release the center, that's going to suck. Getting ready to fire. In 3, 2, 1, release. Okay. Whatever was in there is no longer in there, but I have no idea where it went. Oh. And resetting. Ready for another attempt. This thing is a lot slower to reset than any of the other designs. Should not come as a surprise to anyone, really. Let's try launch again. This massive trebuchet. And 3, 2, 1, launch. Oh yeah! Cool! It actually worked! It totally worked! It didn't work well, but it totally worked. Oh man. So cool. This was never going to be the design used. I will wholeheartedly admit that. But you can absolutely make a counterweight trebuchet in Space Engineers that actually launches stuff. I wonder if I reshape the cup so that it kind of slopes downward a little bit, whether it'd work. I suppose the other thing to try, instead of reshaping the cup, what if we use a landing gear and I try and control the release timing? This is slightly terrifying. I might have my finger hovering over the X key just in case I fall off. Okay, now we need a landing gear. Probably there will work. Phew. So worried I didn't have the parts then. If I go... Oh, I'm going to have to hover for this, aren't I? Alright, let's reload this thing one more time and launch with an actual control for the release. I wonder if I can do it better than what it would... than the cup design's going to do it. Oh, that is quick. That is quick. That is probably too quick. I probably shouldn't have done that. I should have done them one by one. Oh, that is not looking healthy down there. I can't believe that managed to stay together. I'm so glad I made this tower tall enough that everything can swing through and not hit any other objects. That was a really important part of how I laid this out. I was trying very carefully to make sure everything could swing through. The only thing that can't is these mass blocks. Is this group of mass blocks. They will hit this rotor if I manage to make that happen. I've done something very, very wrong. Alright, so this time I need to hit button 1 and then hit button 4 right at the top to see if I can get the thing to go further. So, let's crouch so I can see a bit more. 3, 2, 1, launch. Oh yeah! Oh yes! Look at that go! Oh heck yeah! I think I got the full range! Oh, I was not expecting that! 900, yes! Yes! Oh man, I actually made the trebuchet work properly! Oh, that's so cool. That is such a ridiculously over-engineered piece of equipment. And it's totally not functional. But it is so awesome. I almost want to leave it here. Except for the fact that I know a drone is going to crash into it at once at some point and bring it crashing down. But oh man, that totally worked. Yes. All right. So back to the more realistic designs for our assault. To my mind, it comes down to 3 designs. It comes down to our ballista, our catapult with the pistons providing the torque, and the wheels-based launcher. The way I think I'm going to go about doing this is I'm going to build a basic platform for these catapults, for these launchers, I should say, that I will first build this catapult, see if it flips the platform, then see how accurately I can get it if it doesn't. If it does flip the platform, then I'm going to go straight to this one and test it. If it also flips the platform, then the wheel launcher is the way to go. But what I'd like to do is have one of these and one of these, if both of these work, because I think they're kind of the more ridiculous and fun ones. The wheel launcher is pretty cool, but I don't know. The mechanics of these ones just seems like so much fun. I mean, if I end up having enough space and enough time, I might make all three, but these two would be my preference. So there's building all those and plenty more to come, and I will see you then.